Welcome to the Explainer. Today, we're going to break down one of the most fundamental concepts in all of science. We're talking about matter, the very stuff that makes up, well, everything.
So let's just jump right in with a little puzzle. Think about your phone, which is solid, the water you drink, which is liquid, and the air you're breathing right now. What on earth could all three of those possibly have in common?
And the answer is, they're all matter. That's it. It's the big umbrella term for the physical stuff of our universe. Basically, if it has mass and it takes up space, you can call it matter.
Okay, so what is this stuff really? What's the secret ingredient that makes up the entire universe? Let's dig in.
Well, it turns out that everything, from a solid rock to the air itself, is built from countless, unimaginably tiny particles that are always moving. Think of them as the universe's ultimate Lego bricks.
And here's the really cool part. All of these trillions upon trillions of particles, they all play by the exact same 4 simple rules. And if you get these rules, you'll totally get what matter is all about.
Okay, rule number 1. They are ridiculously small. I mean, so small it's hard to even wrap your head around. We're talking about 1,000 billion particles fitting inside one single drop of water. It's just incredible.
Rule number 2, there are actually empty spaces between them, and you can see this for yourself. If you stir a spoonful of sugar into a glass of water, you'll notice the water level doesn't really rise, so why not? Well, it's because those little sugar particles are slipping right into the empty gaps between the water particles. Pretty clever, right? And rule number 3, they are always moving. They never ever stop. In a solid, they're packed in so tight they can only vibrate in place. In a liquid, they've got a bit more wiggle room, so they slide past each other. And in a gas, they're just completely free, zooming around like crazy. And finally, rule 4, they attract each other. The strength of this attraction, this pull they have on one another, is what defines the world we see. Some hold on tight, while others are a lot more casual about it. So when you put those 4 rules together, tiny size, empty space, constant motion, and attraction, what do you get? You get the 3 famous states of matter we all know and love. And this table here just lays it all out beautifully. Look at solids. Particles are packed tight, the attraction is super strong, and that's why they have a fixed shape. Then jump all the way over to gases. The particles are far apart with almost no attraction, so they just expand and fill up any space they're in. And liquids, they're that perfect middle ground. Okay, so we've got these different states, but of course they can change. Ice melts, water boils. So how does that big transformation actually work on a particle level? Well, the secret ingredient here is energy. When you add heat, you're just pumping energy into those particles. It makes them move faster and faster, until eventually they're moving so fast they can actually break free from the forces holding them together.
But here is a fascinating little science puzzle for you. If you put a thermometer into a cup of melting ice, you'll see the temperature gets completely stuck at 0 degrees Celsius. It will not budge until the very last sliver of ice is gone, even if you keep heating it. So where is all that extra energy going?
It's a great question, because you'd think the temperature would just keep going up and up. But it doesn't. That heat energy is being used for something else, something really important. It's not making the particles move any faster. Instead, it's being used to break the bonds between them. This is called latent heat. Latent basically means hidden. It's this hidden energy whose only job is to do the hard work of prying those particles apart so they can change from a solid to a liquid. Once all the bonds are broken, then the temperature can start to rise again.
So what if a substance just decides to skip a state entirely? Yep, that can happen. It's a special case, and it's really, really cool. The process is called sublimation. It's a direct flight from solid to gas, completely skipping the liquid phase, no layovers. And the most famous example of this is solid carbon dioxide.
You probably know it as dry ice, and now you know exactly why it's called that. It's dry because it never melts into a wet puddle.
At room temperature, it just transforms from a solid block straight into this spooky, awesome cloud of gas, right before your very eyes.
So when you really step back and think about it, the solid, stable world we feel is mostly just empty space. It's this beautiful, elegant dance of countless tiny particles, all held together by invisible forces. Which brings us to one last, kind of mind-bending question to leave you with. What does it even mean to touch something?
Thank you for watching. If you like the video, like, share and subscribe.